In this video, I'm going to go over the program that we had, or programs that we had for lab yesterday. So this is from lab one. So this is the int collection class that we copied over from the server that was already done for us. And I think it's fairly complete. We may have to add stuff, so we'll see. The assignment asks you to create separate header files for all this, but what I've done, I've just combined it into one for simplicity's sake on doing this video. So I need to rename this. I didn't. I thought I did, but I guess I popped up the wrong one. I should be doing this in the .cpp, but I can change that later. Okay. So the first thing I ask you to do is to create this front remove collection, which I've typed in the class there, and it's going to be a child of, okay, so I put the colon there, the int collection, okay, which is right up there, okay, but it's public, so I need to put in public, okay, and that should be all we have to do to set up the inheritance, okay. So I can then go ahead and start coding this. I like to put this in always at the front or right at the beginning of this, just because I tend to forget that semicolon because it's weird, okay. So we have our private data. Okay, and this comes from the problem description itself. Okay, so we have to look back to that, and it says that we need a dynamic array for called data, a dynamic array of ints. We need an int for a counter, and we need an int for a capacity. Okay, so we've got our int star star data. Okay, that's how we're going to create the space or the header for the beginning of our array. Okay. We have an int for the count. That's what we currently have in the array. And then we have the int for the capacity. Okay. Should be all we need. We can add more later if we need to. And then the public section, we have to have our constructor. So our front remove collection. Okay. That has no type at all. Okay. It's going to take the capacity, but we can start this off by giving it a default value of, let's say 10. So if they don't say, if they just say create a new one, then we're going to create it as one of 10. Okay. And we're also going to have our front, sorry, the destructor, which is going to be the tilde front remove collection. And since I'm doing these in the same file, this won't be just a prototype. This will be the actual stuff. Okay, same thing here. This is the destructor. Okay, I have to figure out what we need to remove there. Okay, then we've got the other functions that it tells us to create. So we've got a void function called add, which is going to take an integer. Okay, call it value. And we don't have to, but we should because this is from the original class. Okay, we're going to go ahead and put this override in there. Okay, we'll have to define what that's going to be here in a minute. Then we have an int remove. Okay, it doesn't take anything, but it's going to remove something and remove from the front in this case. Okay, and then we have a Boolean function for is empty. Okay, which just lets us know. Okay, this function can be a constant function, and it's an override. Okay, and it has a body, and this also. This one is not a constant, okay, because it is going to make a change, okay. Actually, add is not a con. Yeah, add's not a constant. That's right. But is empty is constant. It doesn't change anything. Okay, but I do need the override. Okay, so that should set up kind of what things are supposed to look like. And then we can start thinking about how we're going to create each of these functions. So let's go back and start with the constructor. Okay. So for the constructor, where all we have to do really is we have to set the capacity, we have to set the count. Okay, so we're going to create the dynamic array here. And the problem said to create it in the constructor and to get rid of it in the destructor. Okay. So I've got the capacity or the size of the array coming in. Okay. It's going to be equal to the cap, which is being sent in as a parameter. Okay. And if they don't say anything, we'll just default it to 10. Okay. So it won't throw an error. Okay. Our initial count is going to be equal to 0 when we create a new object. And now we're going to set our data, or create the data is equal to new, okay, creating a dynamic array. It's integers, and it's whatever capacity that they set, okay? Again, we should be checking to make sure the capacity is not a negative number or something ridiculous, but we're not for now. We will later, okay? So we're assuming now that the users of this are acting in good faith, okay? The next thing we have to worry about is the destructor, and we've created data with the new keyword, which means we need to delete it, okay, with the delete keyword, okay? Again, this data is going to be in the heap, which means we're responsible for it, okay? When we're deleting something that has more than one memory location in it, we have to put those brackets in there and say delete bracket bracket data, okay? That should take care of that for us. Okay, so then the other things we have to do, we can look at our add. So we have a value, okay? So in our initial condition, we have our capacity of 10 if we don't enter anything else. The count is at 0, okay? So we can add something at that count position. Easy enough, right? The first thing we do, we add at position 0, okay? So all we need to do in here is to say data at position count is equal to value, okay? Then we have to make sure that we increase the count by 1. Okay. Should be all we have to do. Should be okay. It's not a bad idea. For the sake of brevity in this video, I'm not going to do it, but you probably should go ahead and test this along the way. So when you're testing on this, you can just say return 5, okay, if you wanted to test it, if you didn't want to have to write this yet, okay. It won't compile if you don't return an integer, but you don't have to have your function working to test the other functions, okay. So the remove in this case, okay. So let's look at where we're at. We're removing from the front, okay. So if we have an array that looks like 1, 2, 3, okay. When we remove, we're going to end up having 2, 3, right? Okay. So that's the idea of what we're doing. So sometimes a visual helps, okay. And to do this, we're going to need to basically shift the elements to the left. Okay. So we're going to shift the element 2 to the 1, the 3 to the 2, and this one over here, we're not going to have to delete. All we're going to do is reduce the count by 1. So we won't know that it's there. Okay. So this shift element to the left then, it's to left. Okay, we're gonna have a for loop here. So we're gonna have for int I equals 1. So we're gonna start. We're starting at this position, which is 1. Okay. We want to go along until or as long as I is less than the count. Okay. So the count in this case is 3. So this is going to do 1 the first time, 2 the second time, then we're done, which is what we want. Okay, we want position 0, 1 to move. We want 0, 1, 2 to move. Okay, so that should take care of that. Okay. Oh, and then of course we have to make sure we're incrementing our loop. Okay, so we have to have the I++ at the end. Okay. So it's a one-liner, so I don't have to put brackets, but I like them. I think they look cleaner. Okay. So each time through, I'm going to take the data, which is at position um, I minus 1. Okay, so in this case, we're referring to 0 this first time through. It's going to be equal to data at I. Okay, so that way we're not worried about losing anything. So the first time this happens, the data at position I minus 1, which is here, is getting the value next to it. Okay, so after this first version, we're going to have a 2, 2, 3. Okay, run it the second time with 2. Then we're going to set the 1 position here equal to the 2 position. So then we will have a 3. We'll have a 1, sorry, 2, 3, 3 when we're done the second time. Okay. So we'll then have to just change the count to ignore that position that's to the right. Okay. So this should get us through. And then down here, we can do a count minus minus. Okay. So now when looking at the description, it wants us, this is an integer function. It is going to return the element that it removed. Okay. So before we do any of this, we have to set up a variable and say int something like removed value is equal to data at position 0. Okay. Then when we're done down here, we can return that removed value. Okay. That should take care of that. Okay. So the is empty is even simpler, right? The is empty is a Boolean. So if we just return count equal to 0. Okay. So if the count equals 0 is true, this will return true and it's empty. If not, it will return false. If you wanted to, you could say if count equals 0, return true, else return false. That's fine. You just don't need to. This is a quicker way to do it. Okay. So I don't know what it's giving me this error message. Things aren't working because I don't know what that's talking about. Okay, I'm going to go ahead and save this. I should be able to, let me just copy that. Int collection.cpp to int collection. No, I want it to, sorry, that almost went the wrong way. I almost deleted my work. I want to go from .h to .cpp. Okay. So now if I Emacs, I should be able to G++. It's going to say I'm missing an int main, but that's okay. Okay. Doesn't like that for some reason. So let's take a look what it doesn't like about the constructor. Okay, so what have I done here? The constructor, there's not much we're doing here. Okay, so we're in the right area. Okay, oh, I need brackets there. I think that's all it needed. Okay, because it doesn't do anything as far as that goes. So I just need brackets. I think that's all it's missing. Okay, let's take a look. So now let's try it. Okay, there's no main, which is fine. We know there's no main. Okay. So that's not a problem. So let's go back in and we can test this by adding an int main. So in our int main, we can create this front remove collection. Okay. Let's send it a 15 just to be different. Okay. We'll need to test the other version as well. Okay. And then we should be able to do something like, oh, I have to give it a name. So do I put, I always forget the order which I put that in. So let me think about how we're going to do this. Okay, so it's going to be equal. Oh, I need the new keyword because we're creating the data structure. Okay, so I want to say the following. Oh, we're missing something. We're missing something, I think, in the constructor. Let me think about this. Do I need to call the constructor of the the parent? There's nothing that's just in the parent, so I don't need to. Okay, we have to worry about that. If there were some non-virtual items in the parent, we would have to call the parent constructor to set those, but we don't have those. So that should be okay. Okay, so if I want to create a new version of this, okay, because it's a dynamic array, got to do something different. So let's do it this way. Okay. Oh, that's not why you have to do that. I'm looking at my notes here. It's because remember that it asks us to do pointers to these to test the polymorphism. So that's what we're doing here. Okay, so this is not just a normal test. Okay, the other way would have been a normal test. But in this case, to test polymorphism, we're going to say int collection, okay, a pointer first is equal to, that's going to be a new front remove collection. Okay, and we're not going to send it any parameters this first time, but if so, we could put it. If we wanted to do 15, we could put it right here. That would be fine. Okay, so that's going to create a pointer to that. Okay, and we should be able to add some values to it. And since this is a pointer, we would have to do the first add one, first add two, first add three. Okay. And once we have that, we can then worry about testing the other functions. Okay. So we can just check that empty thing. So we can do a cout of first. So one of those wrong way. Remove. Okay. Let's see if that correctly gives us the one in this case. Okay. Get this going in the correct direction. Okay. Then I've got to do my return 0, which I forgot to add at the beginning, which I like to do and didn't do it. Okay. So let's see if this works. Okay. But again, because we're creating that new keyword there, that's different from the other thing we were doing with the data. So we need to delete our first. Okay, let's see if that works. Let's see what havoc I've created. I didn't add stuff at the beginning like I needed to, so I have to include, where's my cursor? There we go. So after this, I can include IO stream, using namespace standard. And we didn't talk about this in class, but hopefully you've seen this before. Basically, what's going on here, it's called a guard, a def guard, okay, that we're creating this variable int collection h in case we include int collection in more than one file. They won't do it twice. That would create an error. Okay, that's all we're doing there. Okay, so that should be okay now. So we should be able to now compile it. Looks okay. Test it, and we do correctly get a 1. Okay, so that should set that up pretty well. And then as far as the second one goes, and I won't go through that entirely because we should have the idea. Uh, it's going to be pretty much like this one. So I can do my Control K to copy it all the way down. Do it twice. Okay. But this time it's going to be the back. Okay. So there's front. Make sure I've got two copies of it. Looks like I do. Yeah, there's class front. So this will be class back. Okay. As the hint says, everything's the same except the remove is different. Okay. So we can talk about the remove real quick here. We have everywhere where it says front, we have to say back. That's going to be the same. That's going to be the same. Add is the same. The remove is what's different. So again, if we have the 1, 2, 3 in there, when we're done after one time, okay, we should have 1, 2, nothing. Okay. So just so not as before, this is different. So we want to return the 3 in this example. Okay. The count is 3, but this is going to be count minus 1, right? Remember, because that is off by 1. Okay. Um, so we can set that equal to count minus 1. We don't have to shift anything. This is really straightforward, right? All we have to do is we can get rid of these. All we really have to do is count minus minus. Note the three's there, but we won't know it. It won't be part of it because the count's there. We add another one, it would add right on top of this, which is fine. Okay. In fact, after this count minus minus, I could just get rid of that variable entirely and just say return data at count at position count. That should do it as well. Okay. The count is now 1 less than it was. Okay. So again, if this is what comes in, the count would be equal to 3. Okay. The count here would be equal to, so the count goes to 2. Okay. 1, 2. And we're returning the count at that 3. That's the initial position. So that would return a 3. Okay. So if we want to test this, we've come this far. I guess we can do the rest of it. Okay. So I can go ahead and copy this as well. Okay. But this is going to be a back remove. We call this second. Okay. Add the same things, but to second. Okay, and then so that should do it, unless I've made a typo, which is very possible. No, looks like it's okay. And we get correctly that 1 was the first time and 3 was the second time. Okay. So that should be what that lab should have looked like. Again, you have variations you could have done for sure, but that's the basic idea. Okay. So if you have questions with that, make sure that you let me know.